Good morning, friends. So this video, we are going to discuss about Apache Kafka introduction, right? So Apache Kafka is known as a distributed streaming platform. So I'll come to what is distributed streaming platform in the subsequent slides, right? But before that, Apache Kafka is also known as a message broker. Normally we have message brokers like ActiveMQ, RabbitMQ, IBMMQ, right? We use messaging brokers for sending the messages in asynchronous fashion, right? Especially when it comes to asynchronous, normally we use email for asynchronous communication. Similarly, we use messaging for asynchronous communication. So what do we mean by asynchronous communication here? Asynchronous in the sense, when a producer is sending a message, okay, so the consumer need not be online, right? Because there is no method call. So normal synchronous, what happens is there would be one service which exposes some methods and the client is going to call that method. But in the case of asynchronous communication, when it comes to messaging, so the producer and consumers, they're loosely coupled, right? Producer is like a sender sending the messages, consumer is like a consumer consuming the messages. In the real time, we can think these producer consumers are like two microservices also, right? So what is message broker? Message broker is a software that enables applications, systems, and services to communicate with each other and exchange the information, right? So that's the main purpose of going for message broker. So Kafka is known as a message broker, right? So in the message broker, we have the concept of topic. So there is actually, when you say message destination, there is a queue and topic. But when it comes to Kafka, we create a topic. The topic itself can act like a queue. So what is the difference between queue and topic here? Queue is point-to-point communication. Topic is publish and subscribe. In the case of queue, what happens is the message will go to only one consumer, right? Especially when it comes to the banking transaction and the customer performs some banking transaction, the customer is going to get some alerts, right? How much money is debited, credited. So that uses kind of queue. But topic is nothing but publish and subscribe model, where the banks wants to give some promotions, offerings to all the subscribers. So the same message can go to multiple consumers. That is what is a topic, right? In a typical traditional messaging system, we have the concept of queue and topic. But when it comes to Kafka, we create a topic. The topic itself can act like a queue also. So that we will discuss continuation, right? So topic is like a, if you see topic, it is a category or feed name to which records are stored. So topics are divided into number of partitions, right? So if you observe here, so the topic is having partition where the records are stored like this. So what is this records? These records are nothing but part of stream, right? For example, here if you see, if I go back to the definition of stream here, see the stream. Stream is a continuous high-speed transfer of large amounts of data from source system to target, right? For example, producer is sending the continuous records, unbounded records to the message broker, right? Similarly, consumer can consume those records, right? So the stream contains continuous records. So each record is nothing but key and value pair. So here you see this is the stream, and here each individual record is nothing but key and value pair, right? So if you look at this topic, like we discussed the topic divided into number of partitions. So here, what is partition? Partition allows you to parallelize a topic by splitting the data into particular topic across multiple brokers. So this is one kind of parallel processing which is provided by Kafka, right? So here, there could be more than one partition. Like I said, the topic can have more than one partition, so that the producer can send messages to different partitions. Consumer also can consume messages from different partitions by supporting parallel processing, right? So similarly, there could be distributed platform here. So it's not just one message broker. We can have, in a clustered environment, we can have multiple message brokers. In that case, the same topic is spread across all the brokers. We can call it as a distributed topic, where these partitions also, they're also divided into all the brokers, right? So that we will discuss continuation, right? So what is Kafka is all about? Kafka is all about a distributed streaming platform, distributed, partitioned, replicated commit log service. So distributed is nothing but multiple brokers, right? Partition is nothing but the topic divided into number of partitions, right? And these partitions can spread across multiple brokers, right? Each broker can act like a leader for some partitions and follower for other partitions, right? So that we will discuss continuation. If you look at this, for example, if there is a topic, order some topic which has 3 partitions, right? Then if there are 3 brokers are there, each broker would be leader for one partition here. Assume that this entire thing is like topic order. In the broker 1, there is a partition 0, partition 1 and 2 here. Similarly, all the brokers are having partition 0, 1 and 2. But if you see the red mark here, so this red, whatever color you are seeing, that is the leader partition. For example, broker 1 is the leader for partition 0, follower for partition 1 and 2. Similarly, broker 2 is the leader for partition 1, follower for this. Broker 3 is the leader for partition 2 and follower for this. So the advantage of this leader and follower concept is for high availability perspective. At any time leader is down, one of the follower can become leader so that the message will be highly available, right? So that is how it works actually. And these followers continuously at different intervals sync with leader, right? So they will send request to the leader saying that any changes are there, automatically those things will get replicated, right? So that is how it works. So that is what is the definition of replicated commit log service, right? Then, so you can see the bigger architecture of Kafka, right? So in the Kafka cluster, you see this is a Kafka cluster where we have more than one broker, and the topic is having partitions. Those partitions are spread across the brokers, right? And this Kafka cluster runs on top of Zookeeper. So normally, whenever we want to start Kafka, first we need to start Zookeeper. So Zookeeper is where all the Kafka brokers information, metadata information, everything will be stored in Zookeeper, which is a distributed configuration management system, right? And if you look at this, there are producers and consumers, right? The producer will be pushing some message to Kafka topics, consumer will be consuming from the topic, right? So that is how it works actually. There could be more than one consumer also, right? Now, if you look at this diagram here, so there is a Kafka broker, with there is a topic order and which has one partition. First, let us take one partition, right? And here, this partition contains offsets. Every partition you see, there's an offsets. Offset is nothing but which is a unique identifier of a record within the partition, right? For example, offset is like it starts from 0, 1, 2, 3 like that. So when a producer sends a message to partition, right, in the topic, if there is one partition, so all the messages will come to that partition, right? So first message comes into offset 0. Similarly, second message offset 1. Like that, the message will be stored here, right? Assume that here the producer is like order service and there is a consumer which is a fraud service, right? Whenever order is placed, to detect the fraud in that order, there is a fraud service which will consume the message and process it, right? So the consumer will read from starting from 0th offset, right? 0 offset. Similarly, the other offsets also, right? Suppose if there are more than one partition, when the producer is sending message to more than one partitions, then those messages can be load balanced. Normally, when the message producer is sending messages, you know, the message comes in the form of record, which contains key and value. But key is optional. Value is mandatory, right? Assume that there is no key, only value is given, then those messages are round robin. So those messages are sent to Kafka broker partitions in a round robin fashion. That means first message may go to partition 0, next message may come here, third message may go here, fourth message may come here, actually, right? This is how the load balancing will happen. But if the message has a key, then there is an algorithm actually, there is a hash code of that key, then mod of number of partitions. So based on that, the message will be pushed to some specific partitions. Especially the messages which are coming with the same key can come to same partition, right? So in the Kafka topic, the messages are ordered only within the partition. So whatever messages are there in partition 0, they are ordered. Partition 1, it is ordered, but the entire topic level messages are not ordered. Just understand. So anytime we are looking for some kind of order in the messages, those messages must come into same partition, right? So Kafka guarantees ordering within the partition. That is what I mentioned. Whenever we producer sending some messages, producer can give some key so that the messages with the same key can come to same partition, right? So in this case, there is a consumer fraud service consuming the message from both the partitions, right? But here it is like a sequential. So the consumer will consume from first to partition 0, then comes to partition 1. Here we are not really getting the advantage of the partitions, right? When the advantage of multiple partitions comes is if there is more than one consumer, right? That is where the parallel processing will happen. So here you can observe there is the fraud service group where there are two consumers are there, right? When there are two partitions and two consumers are there, each consumer would be exclusive to one partition, right? For example, the consumer 1 of the fraud service group will read message from partition 0 and another consumer will read from partition 1. This is how the parallel processing will be supported by Kafka, right? But these consumers must come with the same group, right? And within the group, if you observe, for example, within the group, we have two consumers. Each consumer is exclusive to one partition, right? So the messages are not duplicated. At any point of time, two consumers within the same group cannot read message from the same partition. That means this is something like typical queue functionality, right? Even though it is a topic, but within the group, it is like a queue because only one consumer can consume the messages. There is no duplicates, right? But if there are multiple consumer groups, but same message can be delivered to multiple consumer groups, right? Similarly, if you observe here, if you add one more consumer here, right? When you add one more consumer, this consumer would be idle. The reason is the number of consumers within the group must be less than equal to available partitions. If consumers are more than the available partition, some of the consumers would be idle, right? Because here the consumer 1 is pointing to partition 0, consumer 2 is pointing to partition 1, and for consumer 3, there is no other partition. This consumer 3 is idle. But any point of time, if any one of these consumer is down, automatically this consumer can take the leadership of that partition, right? High availability perspective, this is useful. Otherwise, this would be wasting the resources, right? Similarly, if you look at this example, so here this is how the consumer reads from different partitions, right? Similarly, when it comes to another service called inventory service, right? Say for example here, now there are two groups. One is fraud service group, second one is inventory service group, right? So fraud service group is having some consumers, similarly inventory service group is having consumers. Now, both the consumer groups are pointing to same topic, you can observe here. This is a typical publish and subscribe model, right? So whenever order service push some messages and there are two services are interested for this, two group of services, right? For example, fraud service and inventory service, right? In that case, the same message can come to both the groups. So here in the fraud service group, consumer 1 is pointing to partition 0, start reading the messages. Similarly, consumer 2 is pointing to partition 1, start reading the messages. At the same time, from inventory service group, consumer 1 is reading the message from partition 0, consumer 2 is reading message from partition 1, right? Normally, the main purpose of topic is not that whoever subscribes to the topic, they can get one copy of messages, right? So similarly, if you observe here, say for example, this fraud service consumer reads first 0 to 3 messages, right? Then after that, the consumer says, say I processed 3 messages, 0 to 3 offset successfully. Is there any way I can process remaining messages at a later time? It is not that, okay, whatever message comes here, all the messages has to be processed by the consumer, right? Consumer can process few messages. At later time, consumer can once again start consuming the message from the committed offset. So if you observe here, so here the Kafka broker says, yes, shall I auto commit the offset? For example, consumer read up to 0 to 3, the Kafka broker can auto commit it. So next time this consumer come back, so the Kafka server can give from the committed message. So that is how the offset will work. That is how the offset can be committed per consumer group. The offset can be committed. So any point of time consumer says, okay, I want from the committed offset. Or the consumer can say, once again, I'll start reading from the first message, right? So for example, here the consumer starts reading from 0 to 3. At any point of time, consumer says, once again, I want to read from 0th offset, right? In that case, consumer has to explicitly mention from where the message has to be, messages are required, right? That is how it works. And one more interesting point is the same consumer can read the messages any number of times. So Kafka point of view, very important thing is whenever a message comes to Kafka, there is a retention time for that. So the default retention period for the message is 7 days, right? Within 7 days, any number of consumers, okay, in the same group or different group can read the messages. Similarly, the consumer can read the message any number of times. Kafka just delivers the message, right? Only thing is here, the retention policy is something which is very important, right? So similarly, if you observe here I told you. So this is how there is a clustered environment where we have multiple brokers, right? And the topic spread across multiple, the topic contains partition, this partition spread across multiple brokers. And here because there are three partitions and there are three brokers, each is acting as a leader. And leader partition is where write and read will happen. For example, the producer can write to partition 0 for broker 1. Producer cannot write partition 0 broker 2 because this is a follower. So read or write, even consumer wants to read also, consumer can read the messages only from the leader partition. So that is how it works. The followers, the main purpose of this replicas or followers are to just sync with the leader so that any failure happens to the leader, automatically these followers can take that leadership, right? That is how it works. So here we have one use case, e-commerce order processing, one use case you can observe here. In this, say for example, we have different Kafka topics, right? One broker can have any number of topics and each topic can have any number of partitions, right? And this example is like a microservices. You can see there are different microservices. There is an order service which exposes REST endpoint to the client, right? So any client place an order, so that those orders comes to order topic, right? So order service is acting like a producer to this order topic. Then who are the consumers for this? For example, fraud service is like a consumer to this. Similarly, there's an email service is a consumer to this. There is an inventory service which is a consumer to this. Similarly, there's an order detail service a consumer to this. So that's what we discuss normally. Whenever a message comes to a topic, particular topic, there could be multiple consumers which are pointing to that particular topic because those consumers are interested for those messages. Those consumers can read the messages, right? And these consumers can be part of different groups, right? For example, this fraud service is part of, here if you see fraud service, there could be a fraud service group where there can be more than one consumers which supports parallel processing. This is what we discussed in the previous examples, right?